motherfuckers. Hello to all the motherfuckers in the world that are watching my videos. uh, hello from Romania, from your favorite artist Alex here. What I built here, actually, this is an upgrade or add-on. I received this soldering iron, and this is brand new, and I love it. It's very good. This is the original one that is coming from here. It's not detachable. It's like that, and it is having a very weird that is copper, but it's blackened right now because it got overheated, and I have to clean it from time to time, and it's because it's bare copper. It's kind of doing its job, but nah, not really anymore. And it's good for other things, for melting plastic, but for soldering per se, not really. And I said to buy another soldering iron like this, and I wanted it to attach it to my already soldering iron control, soldering station, let's say it's like that. And I really had to do a lot of thinking. I built it in, I believe, for 3 or 4 days. Everything that you see here, all this add-on. Let me show you this part here, how it is connecting, and I will explain everything. So this wire that you see it impaled here. By the way, nothing is plugged in. It's out, so I can touch it. I can proudly say I never got electrocuted all this time while I was working with 220 volts. Even live tests, I did some live tests, perfectly safe. So I'm a very good electrician from this point of view. This wire that is coming here, you see here, it's this wire. This is from original box here, and it's going. This is the iron wire. It's the wire for this, and here in the back is the 240 volts to plug it into. So powering to 240 volts from this wire, and this wire was coming out to the iron, and I had to attach this guy to this already blue box somehow, and I really liked how is this conceived, how easy it is to. It's a very good design for this station. Very good. I really like it, how it's built inside, and it's very good. And I wanted the same feeling, when I'm putting it in like this, and I get it. I get that feeling of two soldering irons. This is completely alien. But it's like an add-on to this one. And I have to make all the wiring. I know it looks and feel very simple right now when it's already built and already working. And I can show it. Let me point it like this. If I'm plugging it in. So this is the button here for this. And that's it. There's only one light there that is showing that that guy is hitting. And this is the power. Probably you see some flicking there, but in reality it's not that flickery. Interesting. On video it is flickering from 240 volts. And here it is, 320, really? When I'm turning it on, it was defaulting to 320 degrees Celsius, but now it is fine when I'm closing it off. When I'm turning it on, you see here this little blinky thing, and this one degrees Celsius is also blinking sometimes. If you cut it too short, it will reset itself for some reason. I don't know why, but it did. If you cut the power before it finished heating up pretty much, and is going up for some reason. So this is the LED, which is blinking here in the video, but in reality is not blinking at all. It is blinking at 50 hertz. And let me power it off and also take it off from here. It is the same circuit that I built, so it's having the same circuit that I presented it last time. And it is here is a wire that is going through that hole, you see, all the way back. I made a long hole here, and it's this white wire, and that white wire is going there. And the two blue wires that I'm having there, I don't know how to keep my, these two blue wires here, actually staying by itself. This one and this one are the switch wires. I'm interrupting that wire. From inside, I drag a wire from inside, the blue, and is coming from the board itself, one blue there. And this other blue is going here, inside this plug-in. This is how it's built. I took, now it's plugged off. Let me put it here for 1 second. To actually show you how I build this little plug-in device, and I hope like that. Yeah, it's not the proper way. Let's see, it's cold. No, it's still hot. And I have a screw here in the middle, and voila. And these two wires are coming off. Actually, they should have been straight, and they are not. They are pressed. Yeah, I did a lot of. But the good thing about this way of doing things, like I did it here, is that if something is broken here, you can very quickly replace it. And that's it, 2 wires inside this very customized holes that are fitting perfectly here. Let me put it back here, like that, pretty much. And this is squeezing like into a vise. And if I'm pressing a little bit harder, is not rotating at all, and is keeping them quite okay. And as you can see, I know it's ugly here, and here is one wire that came out, and the other wire is right here on the margin, and this is it. Everywhere from this point to this point, I have a very long wire. The contact is short to both of them, so it's pretty good. This thing, it's very small. It's very small. I like it. This is detachable, of course. I took it out and I put this screw here, and this is a special nut. Let me actually draw it for you, because I don't have another one, or if I have, I will have to search for it, and I don't really find it very quickly. So this is the profile of it. So this is from a side, and this is from the top. Pretty much is what you are seeing there from the top. So this it is having two tooths, long as this side here and this side, and those tooths are eating into the material. They are made for wood, but is working absolutely fine for plastic as well. So when I squeeze it very, very tightly, you know, the two from the other side and from this side, this element got into the plastic. If I'm taking it out, it will remain two lines where it eaten inside. So what this does is not allowing to escape or rotate the entire screw, and remain quite in fixed position to later add another nut here. But I will not add it probably, because I want a little bit more easy. That was it's a little bit easier to just take it out and plug it in like this. It's you know, and put it back here. I wanted it a little bit more easy to take out this plug from here, but this was a very big inconvenience, this little cord that is getting from here, and I had to find a way. And right now, even if it's moving a little bit here, it's absolutely okay, and it's not coming out until I am grabbing it to come out. This is a cardboard that I built. It is pretty much a cardboard wrapped around this. Let me actually show you one model that I have here. So it took me 3 days to think and to test and to try a lot of things until I reached this stage, which I'm happy with it actually. So I put this cardboard. This is a protection, only protection, not to put your finger directly on those contacts that are there. So I wrapped around here, and here are two contacts. Only two of them I used. And on one side is on, one other side is off, and that's it. This is what is doing. It's the same contactor or button model that I used. And okay. And you will say, but it's very easy to do it, no? I will give you a challenge. Try to make it like I make it here. This cube, like that you are seeing here, this is having a special story by itself. I had to really think how to make it. I have here some plans. Let's go through all the plans a little bit. So first of all, I didn't knew how to make it. First of all, to be very stiff, not to play, not to move around. That was the important thing. And I was thinking something like this, conical, exactly like this thing that I'm having here, also from metal sheet. You know, wrap around, and here is actually from wire, very close together, and creating a cone in which the soldering iron to enter. Then I was thinking here as a box that is open on the top. It's completely open on the top, and you lift it and put it this is the entire iron, you know, like into a box. But it's having lateral and protection here and bottom, of course, and it's quite ingenious, quite simplistic, quite interesting. Then I was thinking if I was having wrapped around like this, I can do it the other way, wrapped around like this, and creating the shape of the cone. And then after more thinking, so this is the cone here. So here is the cone part. The other stuff is other stuff. So in the end, I reached this conclusion. I used to make these holes here. Let me put it down a little bit. I used these guys, this one, especially specifically this one, down to the maximum that it could, and I even push it even further, like this, a little bit more inside. As you can see, I can show you. You see, here is a little bit. So I push it inside, not that much, but enough. And what that did, it did. I was kind of lucky. I measured them, and that was smaller than the diameter of this. Is larger a little bit, but for some reason it's fitting absolutely perfectly. If I'm pressing it slightly, you see how it's grabbing and it's staying put, not moving. Quite, I have to force it a little bit. Right now it's having a little bit more play because I did play with it. But if I'm inserting it a little bit more in force, it's just staying there, and that's absolutely fine with me, and I like it as it is right now, and problem solved of this, how to make it stay there in the same in this position. You know, you see how it's grabbing a little bit. It's absolutely perfect like this. Okay, next I had to deal with this diameter that I'm having it here, this diameter, and inside that hole, I used I believe I used 10, this drill bit, I believe. No, even larger. So, I believe it was 13. Let me show you. Ta-da, this guy. It's very, very big. It's a 13 millimeter diameter here. And it did fit absolutely fine, as you can see. It's still grabbing a little bit right now. But it is the same diameter. This is what I used. And it is... it is having a tolerance. It's not fitting, it's not touching this. It's having a little bit of tolerance like that. You know, you see? And it's having like a play. Like this is the 13, what I'm showing you here. And it's having like a little play there. And it's not touching it when I'm centering here. It's not touching either margin. It's just staying in the center. From what I observed so far, because I did look specifically for this problem, if it's touching it. Because probably it's too short here, it's not having time angle. The angle is not that steep. It is a little bit of angle, but when it's coming out too quickly and it's not touching anything there, which is good. It's absolutely fine. This was a very big problem actually. This cube, the element that is holding the soldering iron. The next stuff that I'm having here is how to make this thing here, this problem, how to plug and unplug it, connect it to the 220 to 40 volts, and also deal with this motherfucker here that I'm having that is in the way pretty much, and I had to work around it somehow. And I actually draw it here. Let me take it out. I actually make a drawing with the, you see? Oh, it's not seeing, it's not showing anymore, but it was the contour, the exact contour of this. It was here, and also the legs here, and and it did help me a lot. This drawing here, this contour, to design to reach this stage that I am right now, that you are seeing it right now. Let's see what was the original ideas that I had. This is the first one. This one here is a block of wood. I was thinking on a block of wood with two holes, exactly like this. And rotating. So I was putting a screw through it. This is a screw in the middle, and it was allowing the thing to rotate. But you see, when it's rotating in this pivot here, but it is rotating a little bit, but is beating, the wire is beating into this element, and here is beating into this element. So if I was trying to rotate from this point somewhere, this element, this wood component that I'm having, if I was trying to rotate it from here, from this pivot here, it was not allowing me here or here. So these 2 points were a very big problem to deal with. Then I was thinking to add, I'm having it actually here, I don't know how it's called in English, pivot, let's call it pivot, that is doing this, and I was thinking this element to be catched like this, and then to open it like that, you know, to move it with this plug in it, and move it like that, and taking it out and plug it in and bend it back into shape. But it was a very big problem here how to catch this element to the case that I'm having. And I was very close to make this number 2 idea, to make it like this. I was very close to walk on this. And then I was thinking 2 sides. So this I was splitting it in half and put an iron like that, like a locking them into one single block. But when I was unlocking them from that pin, bended pin, they were having also this component there on the bottom, and it was opening like that. And the entire plug, I could take it out and put it in and bend it back and secure it back. It's an idea. It was an idea, but it was a bit of work to making it. And this guy here, I don't think I remember what I tried. So it's similar to this, but it's not rotating. It's yeah, I believe I know. So to take it out. So similar to this, but this screw was here in this element. So this element was having the screw in it and taking it out exactly like I'm taking it out right now. But the screw was here, you know. But the problem is it's very close to the margin, and I don't have room and space for another for a screw to securely doing it from this side. And then and that's it. Is the 4th idea. What I did here are 4 ideas. This part here, make a fraction of this circuit diagram that I'm having here. This is for the LED that is lit on the front here at 240 volts. And after I finished with all the ideas, I looked more carefully at this element, and I said I imagined that it is the wires are going from here even higher. This rod is even higher somewhere here, you know, and this one as well somewhere here, and then the wires are coming together into this wire, long wire. So I said to myself, here I have plenty of space to actually drill a hole, and I drilled the smallest I could, the 3 millimeter that I'm having right now. And yeah, it was a little bit of risk. Who knows how it's bent inside? Maybe if it was like this, bent, soldered inside, then I was screwed. I could have fucked it up. You see how easy is on and off is absolutely gorgeous. I love it. So this was a very big problem, and this one as well. These 2 problems, and I had to resolve them. Then the 3rd problem is the wiring. The third problem with the wiring was it I had to like 1.5 days, like that, probably only the wiring, to be sure that I'm not fucking it up. I actually I did fuck it up for like 2 times. I wired it wrongly. I mean, too direct. I was putting the 240 volts directly on this element here and powering directly the iron, the soldering iron, but not using the switch. So including the switch and this LED that I'm having here, including, I had to rechange the wires. And I put only 2 screws here. And yeah, let me show you the interior. It's very well done. I really like it, how it's done. This module, this box, if you want. And where are you? My trusty knife. Here it is. Oh, let me take you out. All right. So it's having, like, you see these 2 guys here that are catching here and here, and then these guys are entering into these slots, and these two here are entering here and here and pressing. Very, very good design. I really like it. And this is a cross for good luck, probably. And this is glued here. It's not falling, luckily. Here is the blue wire from the original cable. This is the blue wire here that is coming to this pad here, and from the same spot. So you see this CN wire here that I'm having here with a yellow bond. I linked 2 wires together, and I drag it here on the switch, and the other wire from the other pin of the switch, I hope you can see something there, is coming here and getting out here. That's it. This brown wire is right there. Do you see it? That is the button. It's from the button, and there is the wire that is coming directly from the 240 volts, coming directly to that. I had to take out the entire board 3 times. You take out this knob like this. This is plastic here, is not aluminum. Usually they were making it from aluminum, but this time it's from plastic. This knob, but it's quite resistant and it's okay. And I had to so I had to take out this, unscrew this nut here and push it back and taking it out. And but I will not do it right now. How I catch this thing, this cube here, I'm also, you can see 4 screws there. I hope you can see 4. There are on other side there. You can see that these holes, through them I inserted the screwdriver to actually be able to screw it into the block of wood. And there are 4 of them. This is made with a 6 millimeter diameter drill. And yeah, it was, and I had to be careful not to touch any wire or the board itself when I didn't drill it like that. I actually took this, I made the holes first in the plastic. In the plastic I did the holes from this side. I made the holes, and then I had to figure out a way of getting the position of the holes and transferring them to the block of the wood block that I'm having here. And I did using a paper, simply a paper. I don't think I'm having it anymore. No, I don't have it. But I did. Yeah, it is here. Okay. So this is the position, all 4 holes, and you can see this is angled, and it was quite hard to transfer the holes that I was having on this plastic board into this face that was also inclined. I had to be extra mega careful, but it worked with a piece of paper, and I had to flip it from this side to mark on the wood, and it worked like this with the paper. And then I screw very long screws, like this long, inside it. And I was actually looking in the same time when I choose the holes in the plastic. I was looking here to actually not to catch the hole in the middle, to be on the margins where is full of wood, and not to get on the other side where is the middle hole. So that was a challenge in itself, and it took me good hours until I figured it out. But I did figure it out in the end. So this is the back to the electric parts, and this wire is having a small gap like that. It is round. Let me actually draw it for you. So it is circle, it is round, but it's having a cut here and here. So it's only here round and only here round, and it's like that cut. And this cut is fitting here. It's fitting here, as you can see, for both of them. Very, very well made. I really like it. It's very simple, and it's simple design and efficient. That's all I'm saying. Very, very simple and very efficient. These motherfuckers that I'm having here are called WAGO connectors. They are connecting a single wire, 2 wires together, pretty much, like this. Instead of soldering them, you are using those clamps and you are clamping them. I am not recommending to anyone to buy this motherfuckers clamping. It's big. It's not intuitive to use. It's hard to use. It's big. I don't like it because it's big, and it's no, not the way. But I'm having here a ton of space, and I thought to use one because I never in my life used anything. Not a single WAGO module like this. I never use it anywhere. But in this situation, I thought, well, it's a good idea because I'm having a ton of space there, and I can use it. And instead of soldering those wires, well, I use this WAGO thing. This brown wire and this white wire are the same, on the same line. So this wire white wire and this one. What I did, I took this component 2 times out. I had to take it out from there. It's having a plastic, I don't know if you can see from this distance, it's having a rubber, actually it's very rubbery, silicone like isolator there. It's extremely good isolator, very good. I had to peel it down on the wire to have access to the metallic element there and to solder. Firstly, originally I did solder this wire, long wire. I told you I made some mistakes in the beginning, so I put it directly, this brown wire directly on that pin there, and I inserted it back. I put the board back, and I made the test. Everything was working, but it wasn't correct because I didn't sort including the switch and the LED here, and I had to take everything back again. Take that thing, that plug there out, take out this motherfucker, very good isolator, but it was very hard to take it out, take it back. And then I thought, well, I will put a thinner wire because this is quite, thick. It was thick, and that isolator, it was forced. It was having some areas that was extremely forced because of this thick wires that was soldered there. And then I put a thinner wire. This white wire is a bit more thin than this thicker. You can see how thick the comparison between the two. And here is from the switch there. And this another white wire is going to the LED here through this hole, long hole here on this pad, and from this pad is going directly to the switch when I'm switching on and off, and then it's coming out there, and it's doing exactly what I wanted to do. And it was crazy work, crazy work, very hard, because I made mistakes and I had to come back and repair the mistakes pretty much, and I learned how to mount everything back quite good. I'm very good at mounting it back as it was. Let's see if I can do it on the camera. Excellent. You see how perfectly it's fitting there? Absolutely good. I'm happy that it didn't fucking up on the camera when I was filming, so it was perfect. I have to feel this is getting quite easy if you catch the already made screw shape into the plastic. You see it's a bit white, and it's the plastic that it got originally shaped into. But if you don't catch that track that is already there, it will be very hard. And ideally is to catch it and to feel into it without making another track. That's very dumb, it's very stupid, and for the moment I will put only 2 of them because it's enough. And this is it. This is all the I really had to think on this, how to make it. I really wanted it to be up and down and not left and right, because I was having the other option to have it left and right, but I wanted it up and down exactly like here. This is on and this is off. When they are down are off, and when they are up is on. And I followed the same feeling like here, and I really wanted a very big, I'm not sure here how, this is only for protection. This is cardboard here that I glued, is glued here, and I make it like a hinge like this. But if I'm dragging it, it will get loose from the glue that is having there. And I'm really proud of how it came out. It's quite reasonable protected. For me touching it with my fingers and electrocute myself, it's reasonable. Here, by the way, here and here are directly to 20 volts, to 40 volts, the mains on these 2 pads, and I'm having this additional little thing that is going like this. I will have to, right now at the moment is staying a little bit like a spring. So yes, this is it. Thank you very much, and see you later, alligator, motherfuckers. Yes, this is it, pretty much. And let me show you it for last time. This was on. This is on. That is off. This is off separately. This is separate, and this is separate as well. Yeah. All right. Thank you very much.